Go ahead.
Very good. Hello, I'm Valentin. I'm the lead developer for the CernVM file system. And thanks for the invitation and you all listened to a lot of technical details about CernVM-FS. You might know it as the file system layer of Easy. So this is basically what powers the software distribution of Easy. And I'll talk a little bit about various topics that relate to Easy. So first is a bit the containerized setup and the road to Kubernetes deployments. I'll talk about the partial replication feature for Stratum ones that were already discussed at the last workshop here. And now finally we have a prototype. Then there's a few smaller topics in the client. There's an upcoming file bundle feature. We have a little bit on monitoring, and then the container distribution, like not the container running CVM-FS in containers, but actually putting containers on CVM-FS, the other way around. So a lot of what I'm talking about is actually going to be in the upcoming release 2.14. Here we have already tagged the pre-release. So basically the major changes that affect the core of CVM-FS are in, and they're being tested right now in various QA nodes. And probably we'll add in a few of these prototypes that I'm going to talk about still before the release is actually then released in around June, sometime before summer this year. A few of the things will be done in the upcoming and the next release. We typically have 1 to 2 a year, so that's about the timeline here. All right. So since I have a lot of stuff to cover, I'll only give the briefest of introductions, but Lara has already given a nice overview of how CVM-FS is used for Easy, right? The basic idea of CVM-FS is that it's an on-demand, read-only file system that is really aggressively optimized for software distribution. In the end, there's like sometimes we call it kind of like a streaming service for scientific software binaries. You can also think a bit about, I don't know, this kind of like bash hook that tells you, I'm trying to access this command which hasn't been installed yet. Would you like to fetch it? And in the end, it's kind of like the radical extension of this idea that kind of like if you then access Python or after you've set this up, then you really automatically download it from a server and then do this basically on the fly. Which basically also at this point you also really can skip the actual package manager. So that this is the general idea. All right. A brief point, I'm going to talk a lot about this CVM-FS client and server, which is a bit of a jargon. What we typically mean here, CVM-FS is a file system in user space, and that's typically when we say a client. This is the process that implements the file system. Basically, that does when you do an ls on CVM-FS, that answers this syscall and then fetches files on demand over HTTP from the server. The server itself that we use typically is very plain HTTP, but what we mean is basically these are tools that are used to publish new software. So it's typically only really the operators that actually use these, and I think Easy also has this nice automated pipeline. So probably you don't even use these than typically very often, but they're still important. Like is an important piece of the system, and to get these working well is an important thing. So the basic idea about these server tools, and the thing is like the secret of CVM-FS is, if you want, is that actually what we serve is data from a content addressed object store. So we take kind of like all of the files that would be in some package. Here's Python, right? And then we use these tools to compress them and hash them and place them in this kind of like hashed content addressed format. And all of the metadata, kind of like the file names, the ACLs, the timestamps, all of this stuff, this goes into a special format, a metadata format that we call a catalog. And this is actually going to be placed alongside the files in this object store. And this also has the effect that also the metadata of a repository can be loaded on demand. So that basically is the same way that all of this works. Now, historically, all of this ran on kind of like one fixed standalone machine, like a publisher VM. We actually have virtual machine in the name, So this may be not surprising. It's actually the reason why it's called CernVM-FS. Not everybody may know, but in the origin of the project is actually really in virtual machines. So it was at the height of the time when virtual machine was all the rage. There was really an idea to run everything inside virtual machines. And then such a CernVM-FS was really the file system that was used to distribute the OS for this virtual machine. So it was actually a cool idea. So as you get a really, really small virtual machine image, around 20 megabytes, and then everything else is going to be fetched on demand using CVMFS. All right, but in principle, you have this, for the basic classic deployment, you have the standalone publisher machine. It's a fixed machine, and it's running HTTP via systemd. It's good. And it has overlay-FS mounted. So basically, it's a fuse mount of the CVMFS repository and an overlay on top. And this is actually what allows you to add and change software in particular. So you open a transaction, you change something, it gets recorded as whiteout files or changes, and then you place this stuff in the object store. Now this works well for machine, but it's okay. So maybe I should I skip ahead a little bit. So we have still other deployment options. At one point, we added the option to use S3 instead of just serving a local folder from this publisher machine. And then at one point, people were saying, maybe it would be nice to have several publishers. Like one publisher machine doesn't keep up with all of these things. And then the gateway architecture was added on top. This basically allows several publishers to work on different subparts of the repository. So now you have several machines, a gateway, and all of this stuff. And so this kind of setup already, if you have all of this running on VMs, it already becomes a bit complicated to manage, especially for us, as we need to test all of this. And so this actually was the motivation to look into containerization, was originally for us to get a nicer test setup. Because we want to actually really test this concurrently, publishing, right, sort of to have the whole system. And so we figured, it would actually be really nice if all of these stuff you can start up in containers. But okay, for containerized stuff, you have the problem that I mentioned before. It's not very nice to use systemd, and it's not very nice to use overlay-FS. In the end, you end up with privileged containers that are also a bit painful to set up. So basically here, this actually what a student at one point, what we came up with. You can run this in a container, right? It's just a bit, it's a bit much. So you have to run it privileged. You need to mount things into the container, the C group. Then you need to create volumes to run these mount points on. So that actually was the main thing I wanted to solve, is to have like a simpler setup where you can really have these services that run unpublished, so you can move HTTPD to its own container, and all of this runs in a very simple way. Now to do this, there were a couple of changes that have been landed in 2.14, and those are actually quite nice. So basically, to get this to run, we now can run the creation of a new repository without fuse mounts. We can do tarball ingestion without fuse mounts. And there's a few convenience options, which are also nice to mention. So the mkfs command creates a new repository, and we used to use this also to connect the publisher to a gateway in this model that I was showing before, that you have this. And this was kind of like a huge invocation, and now there's basically a very short command that replaces a very long one. And then there's also a convenience option right now only for this test setup, but I think that could also be nice. Is in principle what you need to put up a new publisher is you have to have signing keys for the repository, and if you connect this to a gateway, you need to copy those around. And so now we actually also have an endpoint on the gateway that lets you download these stuff basically from the gateway on the fly. So the status here, this actually, well, I think I shouldn't have put production, but it's running in our CI pipeline for the testing as a Docker Compose stack. At one point, I believe this part of the code will need somehow a major renovation, as say it kind of like it's showing that we went from this single machine model, added this gateway architecture on top, and now changing stuff again to make it work as containers. At one point, I think that that might get too complex, and we will need to move. But for now, I think that's actually working, and I hope that actually doing like really Helm charts for Kubernetes is then actually only a small step from this. Like once this is running, so okay, this in the end, this all of it is not there yet. But I think there are some people in the community who are interested. I'm sure that Ryan Taylor from Compute Canada can offer some advice here. And if anybody else is interested, do feel free to reach out and let me know about this. All right, so far. Then another topic in the server tools is this partial replication. I think I got an old version of the slides. There's a few stuff I changed on, but never mind. So, I mean, here the motivation is kind of simple, right? I mean, we have this, Lara also showed already this architecture with a central stratum 0, that is the source of the data for the repository. And then we have independent stratum 1s, which keep a copy of the repository. And an HPC site might want to keep a copy of Easy locally, but they might only need one architecture, right? So this is the motivation behind saying, okay, you maybe don't want to have to replicate all of this stuff. And another motivation here is also that why I also wanted to look into is we have these tools like CVM-FS shrink wrap that help with dealing with cases where you can't actually have a CVM-FS mount. And actually this type of feature really helps. Shrink wrap right now, it's a completely independent code base, kind of like its own command with its own code. And this kind of like helps us refactor this stuff and maintain it more effectively in the future. All right, so how will this partial replication work? So I have a prototype here that works by creating a .cvmfs partial replication. And it has kind of like something that is similar to a git ignore. It's basically similar to a git ignore file, right? What you put in here is paths you want to exclude, and you have kind of like a chance also to be a bit more granular and then include stuff inside an excluded tree. You will specify this when doing a snapshot from the stratum 0. And this is also then going to be exposed on the server. So basically then the client is transparent to see this is actually a partially replicated repository. Yeah, sort of this is quite simple. And I'm seeing a comment directly here.
This feels like doing it the wrong way around. You call it partial replication, but you're listing exclusions. It should be partial exclusions, or you should do it the other way around. I want to replicate this.
Good point. Yeah, maybe you want to make it clearer in that sense that you say what you want to keep. Good point. That's right. Good. There's actually one more, like, okay, so when you have a partially replicated repository and you point your clients to this, then there is the question, what happens if a client actually wants to access stuff that has not been replicated here, right? And so here, my first idea was to provide two modes, let's say, of this. One is kind of like to have a failover mode, where basically you contact the nearest full stratum 1. So if clients access something, it basically looks transparent. It looks like you actually have all of the repository, just fetches them over the network from somewhere else, if that's possible. And the second is kind of like the hard fail if you want to avoid this situation that you have the network access. Right. So basically, I have two questions. If somebody has a direct reaction, feel free to answer now. Otherwise, come to me in the break afterwards. Is this actually really needed? Is there a clear preference for one of these modes? If we only have to maintain one, is definitely simpler. And then the second one is: are you expecting that all of these partial stratum 1s are going to be private in the sense that they're then local to the site? and there's no other people outside of this site trying to do snapshots from this partial stratum 1. I'm seeing a hand.
So my question, if you take a step back, is it your intention with this to create sort of like pre-populated squid instances and redesign the architecture from that point of view? That you say, instead of having a local system where there's a squid to optimize some of the traffic, we actually put a locally maintained stratum 1 there that is able to replicate from the stratum 0. So you don't need to squid anymore, and this is going to be a replication for that. Is that the intention of the architecture now, of this change?
So that's a very good question. It's a very similar solution, kind of, right? I mean, this here is kind of more persistent. So here you have kind of like still a full copy of the repository for a given architecture, and you have is kind of like the full information there. And then even if you lose the network connection, kind of like you can do everything. With preloaded squid, you can probably get fairly close to a setup like this.
No, I'm not saying that you should preload, but this looks like conceptually like doing something like that. So, I mean, if the intention is to keep the traffic locally, sort of like from a performance point of view, option 1 is definitely the good one, because you still have the possibility to go over if something isn't there. If the intention is to be on a restricted network, then option 2 is the better option, because otherwise you will create sort of like unexpected traffic, which you have to troubleshoot. Would be my initial reaction.
All right, good.
I mean, even with option 1, I suppose that I think then you have to provide this full stratum 1 URL as an alternative, right? The client gets that back and says, okay, I'll go there. I guess you could still decide, okay, I just return nothing, none, and then I do nothing.
Yeah, in principle, you could say that you don't even want to contact the stratum, another stratum 1 in any case. Typically, the configuration is that in principle, you do want to have as many stratum 1s in your configuration as possible. As if there's a problem, that this allows to do a failover. So in principle, I think you do want to have other stratum 1s configured.
Yeah, I'm just thinking about Hugo's case where you say like, okay, I want this to be a closed network thing, and I never want my clients to go out for whatever reason. Maybe they can't, right? Maybe I already know that they can't go out. And then I might as well tell them from the beginning.
Then probably it's anyway not possible at option 1, right? So if you can't reach another full stratum 1, then anyway it's impossible.
I mean, for me, I think option 1 would be probably the nice. I think that most people would use this to, I don't know, at least have their own full copy without having the full need for an expensive disk, right? Because the amount of trees that we have is getting quite huge, and if you only care about 2 architectures for your system anyway, then again, the nice thing about the failover is that if I ever want to test, like, hey, how would my Zen 4 node perform if I make it consume Zen 2 optimized software, right? Just as a test, at least I could still do that. It's less efficient, but I could still do it. Provides some flexibility.
Unless I'm getting it wrong, but I think option 2 would be ideal for a trusted research environment. This is the software you're getting. You do not have any access to the outside. End of story. If you miss something, back to square one, and at least we know the software you're having is not able to talk to outside. That might be something where I really can see option 2 a very good one.
So we do kind of have a feature that allows you to check that you're always getting the software that has been signed by Easy, right? So it's not necessarily that that you need to restrict kind of like the traffic to another server, because you can be pretty sure that whatever is on that server, it has to be signed kind of like by the private key of Easy. Otherwise, your client won't take it.
if you go for option 2, the error should probably not be EIO, but it non-exist. Because then it will just look as it's not there. It doesn't.
Right.
It's not a hard error. It's just the directory, the file doesn't exist.
Yeah, it's indeed.
EI feels like a little bit harsh.
Yeah. So I think so it's a bit limited what you can do with file system semantics to show an error message to user, right? What I think is what you could do as well is to show the content that is not there owned by the user nobody, right? Or something like this, that then you also kind of like see, oh, this is actually something that you can't actually.
Yeah, but if you show, exist, it will just look as if isn't there, and it wouldn't have been there. And Alice wouldn't show it.
Show that it doesn't actually exist.
Yeah, and Alice wouldn't show the data.
All right, good. I think I should move on. We can then still continue this discussion. So one feature in the client. This is something that is going to be coming up. We actually have a dedicated presentation on this on the next Computing in High Energy Physics conference. Is my colleague George Christodoulis, who's been working on this mostly. So one kind of like downside of CVM-FS is that you do interactive work, right? You open up the Python interpreter, you do import TensorFlow, then you always have a bit of a latency between these individual get commands for the individual files, right? And so this is especially bad for these types of softwares that can kind of like really huge and have a long list of actually small files they need to fetch. So what we're trying to do here is basically that you can define something we call a file bundle for TensorFlow, right? That might be triggered on this init.py file, and that then is basically up to the Stratum 0 maintainers to maintain this list. There's different ways to do it. This was looking at. Basically, we're then trying to fetch we already start fetching all of these files, because we know once you do an import TensorFlow, you probably need all of these, right? So it's something where we hope that we can also speed up a bit how the latency of using CVM-FS in interactive use. All right, a few other topics for monitoring. I don't know if everybody knows that by now we have, thanks to some community contribution, a centrally maintained Prometheus exporter. This has a lot of information about CVM-FS, maybe a bit too much. I put like really some internal metrics in there that are very, very detailed. Maybe we actually need to go back to make them a little less detailed, but it's quite useful. And we also have a student project now in the summer where we hope to, together with Brookhaven National Lab, to actually create a Grafana dashboard template, so you can easily get started to monitoring, in particular the client and the stuff. What we also got a community contribution from a colleague in LHCb is this catalog visualization tool. Kenneth already added software.easy.io here. So this is a website that basically shows you, as I mentioned, catalogs are these metadata stuff things here. And so once in a while it can happen, especially for the experiments, that these get too large. So Easy is doing great, everything green. But some of the experiments, sometimes they struggle with defining these catalogs, so they don't get too large. So this is also more a tool for Stratum 0 maintainers, but it's a very nice one. Also shows that actually you can do very cool things with LLMs. So I think this contribution was also powered by some kind of AI assistant. This is always nice if people with little time get to make a cool contribution to this. So I want to talk still very briefly before we take the break about containers. Is a bit irrelevant here, I know, for Easy, as you have a very nice solution for this with the compatibility layer and Gen2 prefix. But in principle, you also have the possibility of unpacking container images on CVM-FS. And then you get this kind of lazy loading and on-demand that's from CVM-FS. But typically, there are these containerd snapshotters, that projects like StarGC, Sochi, and Nidus, who do similar things. And we actually had a presentation of KubeCon that we perform very competitively with all of these things. And this is a good option. It's very easy to use with tools like Aptainer. I mentioned this here as well because I hope this is somehow visible. Because at CERN we have one actually very, very big repository where people store their container images, which is called unpack.cern.ch. It's been going since a bit more than 5 years. Actually, 2019 is where it started. And you can see that it's been growing like really, really a lot. And if you think that Easy is bigger, so here we are we were 12 terabytes at the top. The problem was basically also that there's never been any real cleanup done. So I was actually quite busy to actually do this cleanup, where we now got this repository down to a reasonable size. I mentioned it also to show you that actually it still scales quite well. Basically, the reason, if you know, like we at CERN, we use CEF-FS free for the backend storage. And for Ceph, you then have to do these operations called index resharding. And so this is the main thing. There were then too many objects in this bucket that really started to slow down this index resharding. But okay. So this is basically now a bit more manageable. But it also got me thinking about how to do this container distribution in a way that is kind of like scalable and nice for the future. And there's been a lot of improvements that have been gone into kind of like the cleanup and the garbage collection of CVM-FS. We've had a lot of discussions about how to actually do asynchronous GC that's not blocking when you trying to do transactions. That is something that is actually, I think, quite useful. And so in the end, what we also really need is having some kind of quotas and expiration for these types of containers, where you typically really want a regular container registry like Harbor that implements all of this stuff. So what actually I'm trying to do at the moment here is to make really a standalone container registry based on CernVM-FS that is a great naming scheme we call CernVM-CR. And basically this is then, okay, our way of trying to then run unpack.cern.ch in the future. Okay, that actually brings me almost to the end. There's a few more things that I've only mentioned. So behind the scenes, there's also been quite a few things that we've been working on behind the scenes, which are not that visible, particularly about the build systems and updates to dependencies. This impacts HTTPS, interestingly, because we vendor libcurl, and actually when we can stop vendoring libcurl, it becomes easier to use system certificates and this stuff. This is one thing that we hear a lot. The garbage collection I've mentioned. CERN-IT also has now a lot of these standalone publishers that I mentioned in the beginning. I think they have almost 100 machines like this because we have a lot of CVM-FS repositories. And so here we're trying to think of a way to make this more cloud-like. And one idea here is to have the possibility to run multiple high availability gateways. So when kind of like one goes down, a publisher can fail over to the next. And then the container distribution that I mentioned already. Right. I think that pretty much brings me to the end. So if you have anything to discuss, there's a bunch of different ways. We have the GitHub. Our source code is all there, right? And we have as well a forum and a MetaMost chat channel, which is quite active. And in particular, if the time now isn't enough to discuss CVM-FS, we do have our own users workshop, which will probably be in February 2027. Unfortunately, I think we're close to finalizing the date. I couldn't announce it now. We'll probably go to Grenoble, to the European synchrotron radiation facility, which should be very nice. But we still have to see when they actually have the auditorium free for us. Okay, and then thanks. Any questions?
Maybe while I'm walking over, I have a comment maybe on the partial replication thing. I mean, you already have a file format for CVM-FS shrink wrap, right? That covers kind of this use case. Why not reuse
I think
that?
it was pretty much reusing this one. That's kind of like the same type of spec file that I think it pretty much reuses the format that we use there.
When you showed the architecture of sort of like going from the old system to the new system, in the old system, you had both the possibility of having the active stratum 1s, but also the passive S3 as being a stratum 1. In the new architecture, I didn't see that coming back. Is that now gone, or do you always need an active, like a container there, or can it be stored on the passive?
No, it can never be completely passive, right? So what you you need S3 or some kind of way to serve files over HTTP.
Yeah, for me,
right?
S3 is passive. There's no userland component next to it that does something like GeoIP or whatever. It
Right.
only hosts the files.
But you need to do the updates, right? You need to keep it up to date, and this
Sure,
is
but that can be done externally.
Yes. Maybe let me. I'm not sure what. So we're talking about like this model here. This is basically like the stratum. Okay, the stratum 1 would look very similar to this, right? Except that yeah, it basically looks pretty similar to this model instead, but only that you don't publish new files, you do snapshots and you pull from the stratum 0 to put stuff into the S3 bucket.
Yeah, so this is also part of the new architecture.
This
having
containerized deployment. Yeah, that would pretty much not change.
Okay,
Yeah.
okay, clear. Yeah.
You had some slide about transaction not being necessary. If you can go back to that.
Transaction, you mean this one?
That one, yes.
With the mountless ingest.
Yeah.
No, so
Yeah.
okay, it's
I hope you're not going to drop the transaction part.
No.
I rely heavily on that.
It's maybe a bit misleading. Yeah,
Yeah.
In the end, behind the scenes, there's still a transaction, but you don't have. So in principle, for CVM-FS, we have the classic way of running CVM-FS server transaction, and then you change stuff on CVM-FS via overlay-FS, and then you publish. Or you have this alternative of this ingest command, which just takes a tarball with changes and publishes this. Behind the scenes, it does an equivalent thing to this transaction.
I need that
yeah, exactly. So it's pretty much.
I'm watching the clock. We're 10 minutes over, and it's a coffee break. So maybe we'll. Thanks very much again.
All right.